Okay, an example 2 part B, you are asked to find the maximum velocity that the motorcycle will attain. Again, the question is, what maximum velocity will the motorcycle attain? Given that acceleration as a function of time is this one. Okay? But before answering that numerically, or going into the equations, let us sketch first the graph of A versus T and the graph of V versus T, so that we will be able to look into the physical meaning of the situation here. So how do we do that? Okay, given this expression for A, so we can just tabulate, no? So I'll say T, that's in seconds, and then this would be my acceleration. So I will plug in several values of T here so that I'll have several points in my graph. Mas madaling i-plot yung curve pag marami tayong points. Okay? So, I'll say I want to calculate when time is 0, time is 3, time is 6. So, magti-3 interval ako. 3 second interval. 9, 12, and then let's say 15. Okay? And then, on your own, you also solve the values of A, kasi yung finished product na ilalagay ko dito para makasave ako ng time sa video, ha? So, itry ninyo on your own and compare the values that you get of A sa values na ilalagay ko. Okay? So, here are our values for values of acceleration at different times. 0, positive 3.42, positive 4.68, 3.78, 0.72. So if you look at the trend, it's increasing from 0 to somehow 6, and then later bumaba, and then pumuntang nag-increase pero negative direction. Okay? So please check if the values are correct. Now, this is our acceleration time graph now. Sorry, let me just fix my camera. Okay. Now, so for acceleration versus time, this would be the points. Okay, let's plot the points here. So my time interval is in by threes, but my acceleration interval is by ones. Okay, so when time is 0, the motorcycle's instantaneous acceleration is 0. When time is 3, it's 3.4. So, more or less, if this is 3.5, 3.4, estimate. So, dyan papasok ulit ang estimation natin. When time is 6, it's 4.6. So, if this is 5, 4.6 is somewhere here. 9 is 3.78. Okay, so bumaba na siya pagdating ng time 9. If this is 4, then 3.78 is a bit lower. Ayan, that's for time 9. And then time 12, it's almost 0, 0.7. So time 12, somewhere here perhaps. And then 15 is negative 4.5. So somewhere here. When time is 15. Okay. So if you check, our acceleration as a function of time is quadratic. So that our best fit line, makikita nyo naman ang pattern, no? So, it's like an upside down bowl. It's a parabolic curve. Okay, more or less. Ayan. So, let's check. According to our graph, no, if I am able to plot this accurately, it says in our graph here that the acceleration, obviously, of the motorcycle is not constant. Hindi ito kagaya sa first example na constant acceleration. Okay? So, in this case, at any instant here, you have a different value of your A. So, if you look at this, from 0 to time 6, this is when acceleration keeps on increasing, positive direction. Pero na naglampas na ng 6, yung acceleration mo natin, bumaba na hanggang nag-0 somewhere here sa 12, no? So, isosolve pa natin yan mamaya kung anong time siya na nag-0. Okay? And then, After ng lampas na time na ito, nag-increase ulit si acceleration pero negatively. So, ano ibig sabihin ng increasing acceleration per time? It means that from time 0 to 6, yung bilis ng pagbabago ng velocity bawat segundo is a number that is increasing. Pero pag nag-decreasing yung acceleration, yung number na nadadagdag sa instantaneous velocity sa bawat second is also bumababa din. Okay? Ayan, so that's our graph. Now for the velocity versus time, ito naman yung mga values natin. So i-plot natin siya. I'll use the red one. So instantaneously, sabi ng problem, it's at rest when time is 0. So 0, ito yung velocity 0 natin. Ito na axis. 3, it's positive 5.67. So, medyo mabilis siya papuntang right kasi positive. So, when time is 3, 5 point something is somewhere here. When time is 6, so biglang nag-increase, no? So, we have naging 18.4 na kaagad yung bilis niya somewhere here. When time is 6. When time is 9, marangkada pa rin, positive 31, somewhere here. When time is 12, ito, nag-increase pa rin siya hanggang almost na siya nag-40. That's around time 12. However, pagpatak ng 15, bumagal, naging 33.8 meters per second na lang siya, pero papunta pa rin right kasi positive. So, 33.4 is somewhere more or less here. Ayan. Tama ba? So, if we sketch our best fit line, more or less, increasing, and then, ayan, decreasing. Hindi na natin alam, no? Kung gusto nyo pang magpatuloy ng sketch dyan, pwede pa. Okay? Ayan. So, let's find out. So, according to our graph here, from 0 to 12, yung line natin lumalayo sa 0 velocity. So, ito yung time na nag-increase siya positive, bumilis yung velocity natin. Okay? And then, dito sa 12 onwards, yung velocity natin nag-decrease. So, I hope you know that if the sign of V and A are the same, those will be the times na bibilis yung particle mo. So, hindi lahat ng positive acceleration, bumilis ka agad ang particle. Iko-compare mo siya sa sign ng velocity. So, in this case, for example, from time 0 to 6, ito, ang velocity natin positive. Yung acceleration natin from 0 to 6 is also positive kasi nasa first quadrant siya. So, we can safely say that from 0 to 6, yung particle speeding up kasi positive velocity, positive acceleration. Let's continue. How about from 6 to 9? So, from time 6 to 9, your velocity is still positive. Nasa first quadrant pa rin. Ito lahat nasa first quadrant, diba? So, positive velocity yan lahat. From 6 to 9. So, dito sa 6 to 9 natin, or kahit na ilampas na natin hanggang dito sa 12. So, from 6 to 12, yung velocity is positive. Dito din sa atin, 6 to 12, itong orange na line na ito, nasa positive acceleration din. So, meaning, positive acceleration, positive velocity, then this time interval, yung motorcycle is speeding up. So, meaning to say, from 0 to 12, you have positive velocity, 0 to sometime 12 here, hindi pa natin ma-sure kung ano talaga yung time na dyan, around 12, positive acceleration. So, ito yung times na speeding up ang particle natin from 0 to 12 kasi positive A, positive V. Pero, pagdating ng 12 something, yung velocity nasa positive pa rin, papunta pa rin siyang right, pero yung orange line natin dito sa acceleration, nasa negative acceleration na territory. So, negative A, positive V, then yung object natin dito, slowing down na siya from around 12 onwards. Okay? So please take note of that. If the velocity and acceleration have the same signs, then the particle is speeding up in that time interval. But if the velocity and acceleration have opposite signs, where example here, v is plus, a is minus, then ito yung time interval na yung object mo slowing down. Kuha ba? Okay, now, let's go to the main question. Kasi babalikan natin to. Pinakita ko lang ito as another reference, no, sa sagot natin dito. So, let's focus on this question now. What is the maximum velocity na maaabot ng motorcycle na merong ganitong mga kinematic equations? Okay, sige. Kuha pa tayo ng isang papel. So, according to our plotted graph, the velocity that is maximum na kayang abutin ng motor, mangyayari around 12 seconds later after na nag-start siya mag-move. Okay? And that is around almost 40, no? Nasa 38.9 when time is 12. But then again, this is not the accurate time yet kasi nagdepend lang tayo sa pinlot ko na graph. So, to be accurate, we have to use some physical principles and a little calculation. Okay? So, again, according sa graph natin, the maximum velocity is almost 40 and it happens around 12. Kaya nga kung sabihin around 12 seconds kasi hindi ako exactly sure kung ano yung exact value dito. Okay? So, tingnan natin kung mag-agree sa graph natin yung actual talaga na calculation. Okay. What's important here is the concept. The important concept here is this. Ang maximum na velocity ng motor natin, mangyayari yan sa time na yung velocity niya instantaneously not changing. Meaning, at that particular point, zero na si acceleration kasi si V hindi na magbabago once ma-achieve niya yung maximum niya. So, what am I talking about? Okay? So, important concept here is this, that the velocity will be maximum at a certain time when the time derivative of your velocity is already zero. Meaning, na-achieve niya yung value na yon tapos at a very short instant of time, hindi siya nag-accelerate kasi zero. Remember, the derivative of velocity is acceleration. So, we can also say that itong Vx magba-maximum sa panahon when the acceleration of that motorcycle is zero. Okay, this is another way of saying na the time derivative of v is zero. Another way of saying is that the acceleration of that instant is zero. So, meaning, hahanapin muna natin ang time or times na zero si acceleration. According sa graph natin, merong dalawang time values na zero si A. And that would be when time is zero, at saka, a certain time value here na hindi tayo specific. Basta it's around 12. Kasi hindi ganun ka-accurate yung graph ko. So, titingnan natin kung dalawang time values din ang lalabas sa solution natin. So, let's determine first at what time ba na si acceleration 0. So, let's go back to our acceleration equation. Okay. This is 1.5t minus 0.12 t squared. Okay? So, we will substitute 0 here kasi gusto nating malaman yung values ng t na ito. So, this becomes 0 and this is as is lang, minus 0.12 t squared. And then, you notice it's already a very obvious quadratic equation. So, i-rewrite natin siya in this standard form. If you recall, ax squared plus bx squared plus c equals 0. Standard equation ng quadratic. So, this becomes, nahin natin to, negative 0.12 t squared plus 1.5t. Wala tayong constant na c, so 0 yan. Equals 0 sa kabila. So, This is a quadratic equation. You can easily encode it in your calculator. So if you recall, for quadratic equation, diba, you have two roots, dalawang values ng x that will make this equation true. So to get the values, you have negative b plus minus, and then you have your b squared minus 4ac over 2a. Ayan. So that, if you plug in the values now, where is my other pen? Murag hapit na mawala ang kalag sa ako ang pen. Okay, let's adjust this. So, the roots for this, I've already done the calculation earlier. I'll have here my first time value is 0. And my other time value is 12.5. Okay? So, obviously, hindi naman pwedeng maximum si velocity when time is 0. Kasi nga alam natin, 0 siya when time is 0. So, hindi ito yung option natin. Eliminate natin siya. So, our option now, our last option is only 12.5. So, now that we have the time, when the v is already not changing, then we can go back to our velocity equation as a function of time. So, we have there, ang Vx natin of t is 0.75 t squared minus 0.04 t cubed. And then, we will plug in the 12.5 here, second, so that this is now 0.75 times 12.5 squared minus 0.04 times 12.5 cubed. So, this is now velocity when time is 12.5. Okay? And then, therefore, the velocity now, when time is 12.5, sabi natin, ito na yung maximum velocity. And this is around positive 30, sana yung kodigo ko, 38.5 meters per second. So, ito yung maximum velocity na naabot niya, and nangyari ito pagpatak ng 12.5. Okay? So, if we go back to our graph, ang sabi natin, ang nakita natin sa graph natin kanina, ang maximum natin dito malapit sa 40 according sa graph. So, check tayo. And then, it's positive. Check pa rin. And then, sabi natin sa prediction natin kanina, it's around 12. So, dito, it's really around 12.5 according to this quadratic equation. So, in our graph here, if we put this completely, when time is 12.5, yan. So, if this is 13, 14, 12.5 is somewhere here. And then, I'll have to go 38 point, ano nga yung answer natin? 38.5. So, 38.5, 35, 38.5 somewhere here. There. Oops. And then, 12.5. 38 is somewhere here. Oops, somewhere here. So, ang graph natin dapat ganyan. Magpipeak siya dyan. Tapos, ganyan. Para, ito na yung Vx max natin, which is positive 38.5 meters per second. Okay? So, not bad sa ginawang approximation natin dito sa graph. Okay? And we're also able to somehow predict with some degree of certainty na it will happen around 12. Pero dito, obviously, nangyari siya at 12.5 seconds according to our calculation. Okay? So, there are several examples to work on. I hope you will work on that. Okay? Thank you.